Okay, we're in section 11, and this is the homework on the improper integrals. We'll certainly go through each example, and what I mean by that is I'll talk you through the solution. All right, some students need to be talked through the solution. Other students are going to look at the answer key. That's fine. The goal, though, is you really need to work independent of me talking you through this or looking at an answer key. All right, so that's your goal. All right, that's the ultimate goal, that you can work through these problems without seeing an answer key. Now, someone says, how do you prepare an answer key? First, I write the problem down on a piece of paper, and then what I do is I work through the problem, and then I have to make it presentable. And that's so typical that what you're doing is working on paper, then making it presentable. Our goal is to get you to present the material to others, right? What does that mean? Typically, it's going to be typed up and typeset the way we're doing here in the notes. I'm not saying you're at that stage yet. What the bottom line is, scratch paper can look awful. You're going to try to refine it to make it look more like my key. Eventually be typing things up. I know certainly in a lot of my classes that I took, and this goes back some time, they were typeset. My solutions were typeset for submission, all right? They weren't put on scrap paper. Does every student do that? No, but that's your ultimate goal, all right? So I'm going to go to the whiteboard and we'll talk through it, all right? So let me go to the whiteboard and we'll do one thing at a time. So I'm going to do new share. Just give me a second to get you here. All right, so this one over here, you know, what they're telling me over here is they want to evaluate this integral, right? I'm just going to go to the next page and I see what the integral is, and I'm gonna write it down next to the problem. And again, I wouldn't, like, my first goal here is not to type the problem up. My first goal on a piece of paper is just to write the problem down. And what would I probably write down? I'd probably go, oh, they want me to do 1 to r, and then f of x was, if you recall, it's x to the minus 8 fifths dx. All right. Then I would probably write down and say, you know, what is the r? And my understanding about the r is I know the r, whatever it is, it can't be in an interval that contains a 0. So I'm just going to say initially, let me just start off with r being greater than 1. All right. Now, could r be less than 1? Of course it could. But right now, I know right now it would be trouble if it contained the number 0. Now, why is that? It would be a division by 0 problem. Right. So let's go through the actual work that I would put down. And what I would do is I wouldn't do the integration. I'll do that later. What I'm going to do is just do the indefinite integral. And that looks pretty easy to do. I'll write this over here. And what's that going to be? Well, let's see what you do. You have to add 1 to the exponent, right? So it's going to be x. If you add 1 to that, that's going to be minus 3 fifths. And then I would divide by minus 3 fifths or multiply by minus 5 thirds, plus some constant of integration. All right. So I'm pretty clear about that. Of course, I'm going to write it a little bit differently. I'm going to write it as minus 5, 3, x to the 3 fifths plus c. I'm going to go up here and write this down now. Now, what am I going to do? Well, I'm going to write the antiderivative down without the c. So what's this going to be? Minus 5 over 3x to the 3 fifths. Let's see. Limits of integration now would be from 1 to r. Let me write this down. And again, we'll look at the key in a moment. Minus 5, 3r to the 3 fifths. All right, let's keep going. And now minus of minus is plus, right? So plus 5 thirds. I'm going to write it a little bit differently. And someone says, why would you do that? I just like to neaten things up. Now, if this was an exam question, I would put a box on it and be done with it. I would wonder if I was right, though. Well, one of the events having an answer key for you is to look at it. And I noticed in the answer key what they did, they just simply factored out 5 thirds. But I'm pretty comfortable I got the same answer. Now, what's the next question? The next question says evaluate the integral, right? Now, this one's improper, so I have to write down the limit problem. And this is written down for me. So it's going to be limit as r goes to infinity. And I've already done the integrations over here. It's 5 thirds, just copied from the prior problem. 1 minus 1 over r to the 3 fifths. All right, now let's see if we can do the limit. And what's nice about the limit, if r is going to infinity, let me point this out to you. This thing on the bottom is going towards infinity. 1 divided by infinity is 0. So I get 5/3. All right, let's do the next one. Next one, they're writing down what I need to do. Again, if I were doing this, let's go to the next page because the answer is going to be over there. So I'll write down what I need to do and I'll go through the work. So they want me to do 1 to 3, 1, 3 minus x to the 3/2 dx. And they're telling me that this is improper. And what does that mean? They're telling me that if I go towards 3, and the way I'm going towards 3, I'm on the interval from 1 to 3. I'm going towards 3 from the left side. So I'd have to write this over here. Limit as r goes to 3 from the left side. You only can approach it for this problem over here. And that's going to be 1 to r, 1 over 3 minus x to the 3/2 dx. Well, I think you probably know what I need to do. I need to do that indefinite integral first. Let me put that down. So what do you get over here? 1 over 3 minus x to the 3/2 dx. And I'm not saying some students can't be faster than I am at this. I guess if you are, that's good. So I'm going to use substitution. What's u? It's 3 minus x. What's du? It's minus dx. Well, let me write this down. I'll put my little star over here. I'm doing some side work over here. So I get, minus du. And on the bottom, I would get u to the 3/2. You got to keep moving around. What do you get over here? Minus. And what would you get over there? You would get, let's see, u to the minus 3/2. That's du. And I'm going to keep moving forward. That's going to be minus. I'm going to add 1 to the exponent. So that's minus 1/2. Divide by minus 1/2 or multiply by minus 2. So this will be plus 2 plus c. All right. So what is it going to be? It's going to be 2 over root u. What's u? Well, I can't remember. It's 3 minus x plus c. Now what am I going to do? Well, I got this part covered. What do I want to do now? I want to do 1 to r. This is my side work on the side. 3 minus x to the 3/2 dx. And I can write this down. What's going to be? Well, that had that derivative without the constant. So 2 over root 3 minus x. Limits of integration would be 1 to r. Let me write that down for you. So it's going to be 2 over the root of 3 minus r minus 2 over, well, that would be root 2, right? I'm going to plug in 1 and it's root 2. Let me go back up here and I'm going to write this down now. And what do I get over here? Limit r goes to 3 from the left. And what do you get over here? Let's write this down. You get 2 root 3 minus r plus, not plus, I'm sorry, minus 2 over root 2. Here comes the trouble. I got to do the limit now. Can I do the limit? Well, what are you doing? You're approaching 3 from the left side. So if you look at the bottom, the numbers on the bottom approach 0 from the right side. And this would become, the limit at the bottom would be actually 0. And what's 2 divided by 0 is an infinity. So this over here is infinite. What does this mean, DNA? This is a non-convergent integral. Let's go look at the work and see how they did. All right, and we got this over here. So I got the infinity down. I got this over here. And again, look at my chicken scratch. You're seeing that over there. And look at the typeset version. Your goal is to present information, not to yourself, by the way, but to others. We talked through it. All right, let's go to number 3. And number 3, they're telling me they want to do this integration over here. Well, write it down for you. They want to do the integration 1 to infinity. This is automatically improper way. It's going to infinity. And you get x to the minus 17 sixteenths dx. So I want to write it as a limit problem, limit. And I'm going to say r goes to infinity. And this goes off 1 to r now. And when you go up here, x to the minus 17 sixteenths dx. Well, you know what? I want to do a little side work over here. And what I want to do is I want to do the integral, this one over here. This is going to be the indefinite rule. And that's pretty easy to do. What do you do? Add 1 to the exponent. So what do you get? X to the, let's see, that would be minus 1/16, right? And then I divide by minus 1/16 or multiply by minus 16 plus c. All right. So let me write this one over here. Limit r goes to infinity. Well, I got to do this now. And what I'm pointing out is I got to do Let me write my side work over here, 1 to r, and that's going to be x to the minus 17/16. I'm going to say r is greater than 1. And what do you have here? Dx. And what would that equal? Well, it's going to be minus 16x to the minus 1/16. Kind of scratchy looking, isn't it? And limits of integration is going to be 1 to r. So what does it give me? Minus 16 over the 6th root of r. And minus a minus would be plus 16. So I'm ready to write this down over here. What's this going to be? 16 minus 16 over the 6th root of r. Whoops. Over the 6th root of r. And what's that limit going to be? Fairly simple. It's 16. All right. We got that work over there for you. All right. So, oh, let's do this one now. Number 4. And number 4 is on the next page. Let me go to that. And someone says, you know, calculus shouldn't be used for this. Let me write down what the integration is and what the problem with it is. So what do you get? You get 0 to 4. And this is me doing scratch work. It's all typed up for you. And again, our goal is to get you to realize that you need to present information to other people. All right. We're just talking through it. Now, what do I know about this thing? Well, I'm noticing it's on the interval from 0 to 4. So the first thing I realize is this is improper because if I put a 4 there, I would have to division by 0. So I have to put down limit as r goes to 4 from the left side, 0 to 4. I'm sorry, to r. I didn't mean to say 4. And then it's going to be this over here. Well, I think you get the idea what I'm going to do now. And what I'm going to do now is again, a little eraser out. I can erase that number line. I don't really need it anymore. All right, so what do? I got to do this indefinite integral business over here. So what's it going to be? 1 over root 4 minus x. Let me repeat this. A lot of students are very quick at this. They don't need to write down the u substitution. And I'm not saying you do. I'm just saying some students do. When you get over here, put this over here. Let's see, that's going to be 1 over u to the half. Well, it's going to be u to the minus 1/2. And then what I do, well, it's going to be minus du then. What's this antiderivative going to be? Well, minus, well, it's going to be, I add 1 to the exponent, so it's going to be root u, but u is actually 4 minus x plus c, and I'm dividing by what, a half, right? That's like multiplying by 2. So I got something pretty simple over here, and I'm going to put that down now for you. So I'm going to go say 0 to r. This would be minus 2. Whoops, I'm sorry about that. It's 1 over 4 minus x dx. What does this equal? Minus 2 root 4 minus x. Limits of integration would be 0 to r. And I think I can write that down. What's that going to give you? Well, it's going to be minus 2 root 4 minus r. Minus a minus is plus. That's going to be 2 root 4, right? And what's 2 root 4? It's 4. So I'm ready to write that down up here. Let's put that down for you. Limit as r goes to 4 from the left of this thing, which is 4 minus 2 root 4 minus r. What do you get over there? Well, again, if you're approaching 4 from the left side, that limit exists. It's going to be 4. All right, let's go to k. Make sure you know that's written down for you. And all that stuff is written over here for you. All right, let's do number 5. And number 5 is improper because you're going off to infinity. All right, so let me put this on the side for you. And the first thing I would do, if this is an exam question, I just write down that this is equal to the limit as r goes to infinity, 3 to infinity, e to the minus 2x dx. All right. Well, you know, maybe I'm getting a little better now. Maybe I could actually do the limit here. And I'm going to say limit. When I say limit, write it down. Whoops, I just made another mistake and I got to erase it now. That's not infinity. That's some finite number r. So r goes to infinity. And what do you get over there? Well, the antiderivative is pretty easy to do. What's that going to be? It's going to be e to the minus 2x over minus 2. So I'm going to say minus a half. Limit's going to be 3 to r. I'm going to put that down now. Limit r goes to infinity. And what do you get over there? I'm getting a little better now. It's going to be, let's see, it's going to be minus 1 over 2 e to the 2r. We'll do the limit later. And then the other one's going to be like minus and minus, which is plus. So it's going to be 1 over 2 e to the 6th power. Now, the big question is, can I do that limit? And I can. It's an easy limit to. What do you get? 1 over 2 e to the 6th. All right, the mistakes happen, by the way. I really mean that. You want to be looking at the keys, and I'm hoping the keys, when they're typed up, are much easier to read than a chicken scratch. All right, let's look at this one over here. And again, discuss some problems over here. Looking at, they say use the comparison test for this over here. Now someone says, I don't even remember you talking about the comparison test. You'd have to go back and read it. All right, so what I'm going to do is, try to find a comparison for this over here. And they're not asking me to integrate it. They're just saying use the comparison test. Now, again, you may have to go back and look at the notes to get a comparison test. And I'm looking at it and I'm realizing it's probably, 1 over something to a power. And I'm looking at this 5th root. Write this down. I'm looking at the 5th root of x8 plus 1. This is going to get tough. And I'm going to say it probably compares to the 5th root of x to the 8th. And someone says, why would you do that? I'm saying it's an easy comparison, right? They look similar, but the question is, who's bigger? I hope you realize that the other guy's bigger. Now, if that's true, right? If this is true, I hope you can agree that if I did this is me thinking through it, that's going to go in the other direction now, right? It's going to look like this. All right. And this over here is equal to 1 over x to the 5 ace. All right. And then the question comes is, why would you do that? It's a comparison. So all I can say now is I know this. And again, this is a positive integral here. 4 to infinity. 1 over the 5th root of x8 plus 1 dx is definitely going to be less than something. And what's it going to be less than? It's going to be less than this guy over here. All right. So I'm going to say that that's good to know, because if this is a, if I can do this limit and this limit turns out to be finite, in other words, it integrates, I know this one would integrate. And that's the whole thing about the Powers Theorem. So let me just quickly go through that for you. And I'll write this one over again. So I'll write down 4 to infinity. This would be x to the minus 8/5 dx. Right, I'm going to write it as a limit problem, getting a little better at this. Limit as r goes to infinity. And this would be 4 to r, x to the minus 8/5 dx. And I'm going to keep moving. And what do you get over here? Limit r goes to infinity. Well, what's that going to be? I have to add 1 to that, right? So that's going to be minus 3/5. And then I divide by minus 3/5 or multiply by minus 5/3. That's going to be 4r. Again, I got to do the limit now. Limit. And again, by practice, I get better. I hope you get better, but anyway. So it's going to be 5 thirds. And that's going to be 4 to the 3/5, right? Minus, let's see, that would be 5 thirds r to the 3/5. All right, can I do that limit? I can. And what's that limit over there going to be? Well, kind of looking at it, that limit's going to be finite, and it's going to be this: 3 times 4 to the 3/5. Again, this is a finite number. So what I know about the comparison test is convergent. Let's just go to the next page. And by the way, I was using the what we call the p is greater than 1. So I didn't do the integration. I just said the P was greater than 1, and it's certainly going to be convergent. And we did that in the prior notes, by the way. But I did the integration. So this is convergent by comparison test. All right, let's do number 7. So determine whether the proper integral converges or not. And, looking at it, I'm wondering, what's the trouble with this one over here? And the trouble is the -9. And let me just go through that with you at a number line. If you had -9 over here, and this is 11, and you're approaching 9 from the right side, what happens? The bottom becomes 0. So what I want to do is I want to write this over here as the limit as r goes to -9 from the right side of it. Yes, that needs to be written. What do you get over here? This will be r, this will be 11. And what do you get over here? You get 1 over the cube root of x plus 9 dx. All right. Again, when I say I'm getting a little better at this, I'm not saying everyone gets better at this. It really requires a lot of practice over here. So I'm gonna just maybe do the integration on the side. And what integration I'm trying to do? I'm trying to do this integration over here, which is going to be x plus 9 to the -1/3 dx. And I think I can do that. All right. With U substitution or not, it doesn't really matter to me. What are you going to get over there? Well, that would turn out to be x plus 9. I have to add 1 to that's 2/3, right? And then what do? You're going to divide by 2/3 or multiply by 3/2 and plus c. So I think I'm ready to put this down now. And let me get my eraser out because I realize that line's getting in my way over here. Look at the key later. And again, this is me doing chicken scratch work. I'm going to say 3/2 limit r goes to 9. I'm sorry, -9 from the right side. And let me do the evaluation now. What's it going to be? Well, it's going to be, I took the 3/2 out already. I'm not going to put the c down either. It's going to be 11 plus 9 is 20 to the 2/3 minus, and now I'm going to do that r. And what's that going to be? R plus 9 to the 2/3. Can I do that limit? I sure can. And what's it going to be? 3/2. And you're going to get what? Times 20 to the 2/3. We'll check the key later. And the other guy's going to be 0. So I got my answer. All right. And this is my answer right over here. Let's look at the key, see how we did. And I think I made a mistake somewhere. And where's my mistake? Maybe I made a mistake in the notes somewhere. Well, I'm going to write this down as, let's write this down. And 20 to the 2/3 is going to be the cube root of 400. Oh yeah, now I see it. So cube root of 400, again, 20 squared is 400, is going to be 8 times 50. And what's cube root of 8 is 2, so 2 root 50. Cube root of 50, I'm sorry. Let's write that down. Times 2 cube root of 50. And what do you get over there? The 2's cancel off. And what do you get? 3 cube root of 50. Let's look at the key again. And I'm seeing that right over there. Now, someone's going to say, would you grade me wrong if I didn't put the simple answer down? No. But I want to tell you, historically, what happened for a lot of students, they weren't given answer keys like this. What they were given is, at the end of the book, there would be odd answers, no answer work though. What they'd write down at the end of the book, they'd write down problem number 7. They'd say answer is 3 cube root of 50, but there would be no work to support that. Now, someone says, why is that? It's a lot of effort to type up a key. It's a lot of effort, all right? But we did the effort for you, all right? So let's keep going. Number 8, a little more complicated. And by that, what I mean is that I'm seeing is an improper integral because it's going off to infinity. But my big issue is just the integrations. And I'll write this over here. And don't worry, we'll just do the integration first. And then I'll talk through the notes for you. I'm looking at it. I certainly don't know its antiderivative. So what I'm going to do is I'm going to make an attempt. I'm going to use that integration by parts. So I'm going to say u is equal to e to the minus 4x, and dv would equal cosine 3x dx. What's du going to be equal to? Well, it's going to be minus e to the minus 4x over 4. And what's v going to be equal to? Sine 3x over 3. All right. So let's put this down. A little pretty tough. So it's a uv. That's going to be e to the minus 4x. And v is sine 3x over 3. Now minus and minus is going to be plus, right? And I'm going to say 1/4. And that's going to be e to the minus 4x. And then it's going to be cosine, I'm sorry, let me make sure, I forgot to put the dx here, sorry about that. And then it's going to be, let's see, that's going to be sine 3x over 3, right? That's going to be let's see, did I do that right? I think I made a mistake somewhere. I got to look at it again. So I said u was equal e to the minus 4x du. Oh, I'm sorry. I see my mistake now. Got to get my eraser out. I got confused with integration and differentiation. It happens sometimes. This is incorrect. So that means this over here is incorrect. Sorry about that. I was daydreaming, and I did like integration when I should have done a differentiation. So it's going to be minus 4 e to the minus 4x dx. Sorry about that. Let's put this down then. So minus minus is plus. That's going to be 4 e to the minus 4x dx. And then the v is going to be sine 3x over 3. I'll put that on the outside. Now someone could say this is a nightmare because it didn't get any easier, by the way. Well, all I know is that this integration here and this integration here basically are the same quality, right? They really haven't gotten any easier. So I'm just going to keep doing it until I see something. And I hope you remember in the past we've done things like this. I'm going to erase this old business though, by the way. The reason for that is I don't need it anymore. I'm already done with that. If this is not working out, I guess I'd have to try again and again and again and again and again. Erase this over here too. So what I want to do is I want to see if I can integrate this guy over here. This is my little side work over here. I'm going to try again. And I'm going to do this u equals e to the minus 4x. du is minus 4 e to the minus 4x dx. And dv is equal to sine 3x dx. And v would equal what? Well, minus cosine 3x over 3. All right, let's write that down. So what do you get over here? You would get, let's see, minus e to the minus 4x cosine 3x over 3. You got that part. Minus and minus is a plus. I got another minus over there. So it's going to be minus, it's going to be tough, 4/3. Let me make sure I did that right. E to the minus 4x. Just give me a moment to think. Dx. And then cosine 3x. All right, it's just crazy. I mean, it's so much work. I don't think I could ever get through it. I got to write this down now. And what do I write down is, I got to take this integration over here, which I just did, but I got to multiply by 4/3, right? Let me write down. I have to be very careful about it. So e to the minus 4x times sine of 3x over 3 minus 4/9. Don't we have the key to check? E to the minus 4x cosine 3x. I think I did it right over there. And then what do you get? Minus 16/9. E to the minus 4x. I gotta be honest with you, looking at this guy over here, it's kind of nightmarish. And I'll tell you why it's nightmarish. I keep coming back to another integral and it just doesn't change the complexity. But what do I notice now? I notice this guy and this guy have identical integrands. So what I'm going to do is I'm going to add them to both sides. And by the way, I'm not saying I didn't make a mistake yet. We'll look at the key later. Erase this business over here. By the way, the problem with erasing is if I erase something, I have no idea what my errors are. All right. So if I did that, what would I get? Well, it would be 25/9, right? E to the minus 4x cosine 3x dx. Yes, I know this is tedious. Equals, well, e to the minus 4x sine 3x over 3 minus 4/9 e to the minus 4x cosine 3x, all integration removed. Now I'm going to put the c down. Now I'm wondering, did I get that right? And before I do that, I got to multiply both sides by 9/25 now. Again, I'm not beyond making mistakes, nor are you. That's why we practice. You get 9/25. So let's say 9/25 times 1/3 is 3/25. And then you're going to get minus, let's see, 4/9 times 9/25 would be 4/25. Write this over here. E to the minus 4x cosine 3x plus c. I'm going to factor that. And I'm going to factor out a 25th on bottom. And I'm going to factor out e to the minus 4x on top. And what do you get? You get 3 sine 3x minus 4 cosine 3x plus c. I wonder if I'm right. I need the next page. And I want to see if I got that. And I can't remember half the things I do in life. Let's see, 3e to the minus 4x over 25 sine 3x. Wow, I got that term right. And I got this term right. Good deal. This is good. So let me, the integration's done. This was, I can't remember why you did that. Well, let's go back. All right. The reason I did that is I got to do this limit thing here. All right. I have to do the limit. All right. I got to do that limit. So what I do, I did this part here. It's going to circle it for you. I know it's a lot of writing for you. Oops, sorry about that. This part we just used from the prior. I'm just evaluating that. And if you do that, you get this over here. Now, why is that so easy to do? Well, plugging in the R, I hope you get, you would get, let's see. Let me see if that's correct. If I plug in R, let's do 0 first. If you plug in 0, what would you get? Let's do that. Well, if you plug in 0, the first term disappears and the second term, again, plugging in 0, the second term would become minus, whoops. The first term would be 0. Second term would be minus 4. I'm doing 0 because it's easy. And then you get e to the 0 is 1. Cosine of 0 is 1. Minus 4/25. Now, of course, we're subtracting that, so it's going to be plus 4/25. I see that. Now, let's see if they plugged in the r right. What would you get? 3 sine 3r, 25 e to the 4r. I'm putting the e's on the bottom for a reason, by the way. And then it'll be minus 4. Whoops, I made a typographical error over here, and I got to correct that. This is cosine. Sorry about that. So I need to correct my notes. I'm hoping you don't see that in your notes, by the way. Let's take the limit now. What's the limit? We're doing a limit over here. Limit is 4/25. Oh, these definitely go to 0 really quickly. So 4/25. We did it. A lot of work over there. All right. There was a small typographical error over there. I'll correct that in the notes later. All right. Let's say I got to look at my clock over here. Yeah, we're doing all right. So this one over here, oh boy. I'm going to do the integration for you. This might be a little bit easier for me to do, but I'm going to do this one over here. I know it's improper, by the way. And I would say u equals, what is u? This is dx, I'm sorry. Wow, it's root x. So du would equal 1 over 2 root x dx. So 2 du would equal 1 over root x dx. I think I can do this now. So what do you get? E to the u. And then I would get 2 du. What do you get over here? 2e to the u, that's going to be square root of x plus c. Let's write this down. This is going to be the limit. It's improper because we're going towards infinity. If 0 were on the interval, I'd have another trouble, but I don't have 0 on the interval. So it's going to be r goes to infinity of that integration. And that integration I just did. So it's going to be 2e to the root x. Integration would be 4 to r. You notice I'm getting quicker at this, right? Let's keep going. And what do I notice right over here? Limit. Let me write this down for you. R goes to infinity. Sorry about that. That would be 2e to the root r minus 2e squared. And what's that going to be? Infinity. So this is a D and A. It doesn't converge. All right. So let's take a look. Now go to the next page. And let's see how we did. And it does say infinity. I just want to make sure I did this thing correct. Yeah, looks good. All right, not bad. All right, another one. Again, I'm getting a little better at this thing. You know, maybe I should just look at my work now. And the reason for that is that, you know, at some point, you probably just want to like say, okay, I can actually, you know, understand what I need to do in this problem over here. And I would say a u substitution like this would be more than appropriate. And, you know, what's the du going to be? Well, the du would be 1 over 2x times 2, and that would be 1 over x dx. I'll put this over here. That looks great. And then I said the dv is this thing over here, and I'm using integration by parts. It seems reasonable if I said that was u, this would be the dv, 1 over x squared dx. I have to integrate that guy. Let me put out what I mean by that. If you're integrating x to the minus 2 dx, that'd be x to the minus 1 over minus 1, which is minus 1 over x. Pretty simple. All right, then what I do, I'm using that, you know, that integration by parts. And what do I get? I get minus the natural log of 2x over x, and minus minus is plus. And then what I get? What would I get? I'd get 1 over x times 1 over x. Oh, that's pretty simple. I got this over here. And this integration appears to be quite simple to write down. All right, now what's the point of writing that integration down is so I can do this over here. And really what we're doing, we're looking to do the limit. And where's the trouble over here? The trouble would be at infinity. So r is going to infinity. And what's that antiderivative going to be? Well, let's write that down for you. It's going to be, let's see, minus the natural log of 2x over x minus 1 over x. Limit integration would be from 1 out to R. All right. So let me just erase some side work over here. And again, we're studying is what we're doing. We're trying to prepare for exams. That's why you study. All right, let's take a look at that limit. And I think I can do it. You know what? I'm going to do the 1 first. And what's the natural log of 1? That's 0, right? So I get 1. And then it's going to be minus the natural log of 2R. Whoops, I forgot the limit, didn't I? 2R over R minus 1 over R. Well, I think I can do that. All right. Now, what I mean by that is this third limit's really simple, just 0. And I hope you realize one over here, you know, maybe you could do L'Hopital's rule if you want. But what I'm starting to realize is that the bottom grows faster than the top. So this is going to be 0 as well. So what do you get? 1. All right. Yeah, mistakes happen. Let's take a look at it. Let's go to the next page. And I made a mistake. And let's see what the mistake is. I see it. I said the natural log of 1. It's not, it's a natural log of 2. I got to erase this now. All right, I made a mistake. Getting sloppy. So it's going to be equal to the limit . And again, I was doing this limit first. So it's minus a minus, which is plus. So it's going to be the natural log. I said 1. It's actually the natural log of 2 because it's twice x over 1. And this will be minus 1 over 1, which is 1. I'm sorry, plus 1 over 1, which is 1. And then the other limit is going to be minus the natural log of 2R over R minus 1 over R. And what does limit produce? The natural log of 2 plus 1. These, again, limits go towards 0 pretty quickly. Let's look at that, make sure we got that right. And we did. 1 plus the natural log of 2. Let me go back and show that to you. All right. Now, again, you have what's, chicken scratch of the board, me talking through the chicken scratch, but it's all typed up for you. You need to start thinking about moving in that direction. Thank you for paying attention. Again, if you have any questions or concern, please feel free to come by during office hours, and I'll be more than happy to help you.